Properties of AB materials. Thermal property. Specific heat. Ever wondered why it takes longer to heat up a pot of water than a frying pan? Or why do some materials feel much cooler to touch than others? The answer lies in the property of a material called specific heat. In this video, we'll break down the concept of specific heat, explore why different materials have different values, and see how it plays a crucial role in everyday life. But first, let us tackle our objectives in this video. First, we need a refrigerator to understand specific heat and its importance. To help quantify a material's ability to store thermal energy, it is crucial for designing efficient thermal storage systems in renewable energy applications. Understanding specific heat aids in selecting materials for optimal thermal management, ensuring safety and efficiency in various industries like electronics, aerospace, and automotive. But first, we need to understand the difference between temperature and heat. Heat refers to the amount of energy in an object, measuring the total kinetic and potential energy contained by the molecules in that object. Temperature refers to the intensity of heat, measuring the average kinetic energy of molecules in a substance. Heat is a form of energy, and temperature is a measure of that energy. What is a specific heat? It is a property of a material that tells us how much thermal energy it takes to raise its temperature. The quantity of heat required to raise the temperature of 1 kilogram of material by 1 degree Celsius. It determines how much heat it can absorb before its temperature changes. Typically expressed in units of joules per kilogram per degree Celsius in SI units. Here we have the relationship between specific heat, heat energy, mass, and change of temperature expressed in the equation. Whereas Q is the heat energy in joules, M is the mass in kilograms, C is the specific heat in joules per kilogram degree Celsius, and delta T is the change of temperature in degrees Celsius. Additionally, some empirical equations could be used to measure the specific heat capacity of a material. These include Siebel's equation, Choi and Okos. Equation: the temperature of a material is a manifestation of the amount of thermal energy it possesses and is heavily influenced by the material's density and heat capacity. The heat capacity of a material is often given with reference to either density, specific heat capacity, or volume, volumetric heat capacity. Quantifying a material's ability to store thermal energy is vital for designing efficient thermal storage systems in renewable energy applications. Quantifying a material's ability to store thermal energy is crucial for designing efficient thermal storage systems that enhance the performance, cost-effectiveness, and sustainability of renewable energy applications. This understanding is key to advancing renewable energy technologies and achieving a more sustainable future. Understanding specific heat is crucial for selecting materials that ensure safety and efficiency in various industries, such as electronics, aerospace, and automotive. By understanding specific heat, engineers and designers can select materials that optimize thermal management, ensuring safety, efficiency, and performance across various industries. This knowledge is fundamental to advancing technology and improving the functionality and reliability of electronic devices, aerospace systems, and automotive vehicles. There are two types of specific heat: the specific heat capacity at constant pressure and the specific heat capacity at constant volume. The specific heat capacity at constant pressure for ideal monoatomic gases is defined as the amount of heat energy supplied to the sample when it is held at constant pressure. Whereas pressure is held constant during the process, it shows a substance's heat capacity when it experiences temperature variations while expanding or shrinking. While the specific heat capacity at a constant volume for monoatomic gases is defined as the amount of heat energy supplied to the sample of gases when it is held at a constant volume. Whereas volume is held constant during the process, it shows a substance's heat capacity when it experiences temperature variations without adjusting the volume. How do you determine the specific heat capacity of a material? To determine the specific heat capacity of a substance, one must use a calorimeter. A calorimeter is a device that measures the amount of heat involved in a chemical reaction, physical change, or heat capacity. The importance of specific heat. In cooking, understanding specific heat helps in choosing the right cookware that heats food evenly. In climate regulation, water's high specific heat helps oceans stabilize temperatures, making coastal areas more temperate. In construction, materials with the right specific heat are chosen to prevent overheating in electronics and machinery. In designing protective clothing, materials with high specific heat provide better protection against heat. Whether it's making a perfect meal, designing safer gadgets, or understanding weather patterns, specific heat plays a vital role in ensuring efficiency, safety, and comfort in our daily lives. So, we've learned that specific heat tells us how much heat a particular substance needs to absorb in order to raise its temperature by 1 degree. Remember, it's not about the total amount of heat, but how easily a material's temperature changes with that heat. Thanks for watching, and don't forget to like, share, and subscribe for more explorations into the fascinating world of science.